Have you ever stopped to think about how your apps in the cloud actually talk to each other or how they connect to the internet? It honestly feels a bit like magic, right? But behind the scenes, there's this incredible invisible network making it all happen. So, in this explainer, we're going to pull back the curtain on cloud networking, starting from the virtual private cloud that you control all the way down to the physical hardware you'll probably never ever see. All right, let's map out our journey. We're going to start by looking at how we got here, the old physical way versus the new virtual world. Then we'll build our very own private skyscraper in the cloud. After that, we'll design the floor plan inside it. And then for the fun part, we'll uncover the real magic that makes it all tick, and we'll even see how the big cloud players stack up against each other. To really appreciate just how much of a game changer cloud networking is, we have to take a quick trip back in time. Imagine a world filled with racks of bulky hardware, a mess of tangled cables, and just a whole lot of manual labor. Yeah, this slide just nails the difference. On the left, you've got the traditional data center. If you wanted a new network segment, you had to physically go rack servers, plug in switches, and run cables. We're talking days, maybe even weeks of work. But on the right, the cloud. It's all just software. You make a few API calls and boof, you have a brand new virtual network in minutes. And that is the fundamental problem that network virtualization completely solves. Okay, so that brings us to the absolute cornerstone of any cloud environment. I want you to picture this. The cloud provider owns a massive, futuristic skyscraper. And what they do is they hand you the keys to your very own private, totally secure floor. While that floor, that's your virtual private cloud, or VPC for short. The two most important words here are logically isolated. Think about it. Your applications are running on the exact same physical hardware as hundreds of other customers, but the VPC acts like a digital force field, drawing a virtual line around your resources that keeps your network completely private and invisible to everyone else. It's your own little slice of the cloud. And look at the level of control you get. You're basically the architect of your own little universe. You get to pick the entire IP address range. That's what CIDR means. It's just a way of defining the size of your network. Then you get to slice that up into smaller networks called subnets. You write all the rules for what traffic gets in and what gets out. It's like having your own virtual data center, but without any of the hardware headaches. Okay, so let's get practical. We have our private floor, our VPC. Now what? Well, now we have to actually design the layout inside. It's time to put up the walls, map out the hallways, and of course, post some security guards at the doors. So the first thing we do is build the rooms. In the cloud world, we call these subnets. A subnet is really just a piece of your VPC's total address space that you carve out for a specific purpose, and that purpose usually have a lot to do with security. And this right here is a really, really critical distinction. A public subnet is kind of like the lobby of your office. It's designed to be accessible from the outside world. This is where you put things like your web servers. A private subnet, on the other hand, is like your secure vault in the back office. It has no direct connection to the internet, which makes it the perfect, safe place for your sensitive databases or internal applications. So how does all the traffic know where to go? Well, there's no physical box with blinking lights. It's all handled by a virtual router. And the brain of that router is something called a routing table. It's basically just a list of rules that says, hey, if a packet is trying to get to this destination, you need to send it through that door. It's the traffic cop for your entire VPC. Now let's talk security. In the cloud, you get two main types of virtual firewalls, or as I like to call them, your virtual bouncers. First up, you have security groups. Think of a security group as a personal bodyguard for one specific server. The cool thing is, they're stateful, which means if you let someone in the door, the bouncer remembers their face and automatically lets them back out. Then you have network ACLs. These guys guard the entrance to an entire subnet, the whole room. But they're stateless, so they have a terrible memory. You have to give them an explicit rule for letting people in and a completely separate rule for letting them out. This table just lays it all out perfectly. A security group is like a keycard for a single office door. It protects one thing at a time, and its rules are allow only. A network ACL is the security guard for the entire floor. It protects the whole subnet, and its rules can be both allow and deny. Honestly, you'll use security groups 99% of the time, but NACLs are there if you need that extra belt and suspenders layer of defense. Okay, so we've designed this amazing virtual network. We've got our VPC, our subnets, our firewalls. It's all defined in software. But how in the world does this actually function on top of shared physical hardware? This is where the real magic happens. Let's peek under the hood.
Well, the secret sauce is this really clever two-layer system. First, you have the underlay. That's the physical stuff. The massive, high-speed web of real switches and fiber optic cables that everyone shares. Then, on top of that, you have the overlay. This is a virtual layer, pure software, that builds private, isolated tunnels for each and every customer, all running over that shared physical network.
So how does it create those tunnels? It's a neat trick called encapsulation, usually using a technology called VXLAN. Let's follow a single packet. Your server creates some data. Before it goes anywhere, the cloud platform wraps it up in a virtual envelope. This envelope gets a special tag, a virtual network ID, that's totally unique to your VPC. Now, the physical network just sees the envelope and knows where to deliver it. Once it arrives at the destination, the system unwraps it, and there's your original private packet, completely untouched. And the result of all this is pretty incredible. Because every customer's traffic is sealed in its own uniquely labeled envelope, you can have literally thousands of different companies running on the same physical gear, each with their own completely custom and private network rules, and they will never, ever bump into each other. It's genius. Now, this all sounds amazing, but you might be thinking, is there a catch? Is there a performance hit for all this virtualization? Let's talk about that, and then see how the big three cloud providers, AWS, Azure, and Google, tackle this challenge. Remember that virtual envelope we talked about? Well, it's not weightless. It adds a little bit of extra data to every single packet that leaves your server, around 50 bytes. We call this encapsulation overhead. It doesn't sound like much, but when you're sending billions of packets, it can add up. But don't worry, the cloud providers have gotten really, really good at managing this. You can see on this chart that virtualization does add a tiny bit of latency. We're talking microseconds here, which is millionths of a second. But here's the clever part. Providers like AWS and Azure use specialized hardware, things like SmartNICs or the AWS Nitro system, to handle all that wrapping and unwrapping. It offloads the work from the main server's brain, which makes the performance almost indistinguishable from running on bare physical hardware. And of course, each of the big players adds their own special flavor. AWS is famous for that Nitro hardware we just mentioned, which gives them incredible performance. Azure has a very similar and robust approach with their virtual networks. And then there's Google, which has this standout feature called a global VPC. It basically treats the entire planet as one big network, which is a seriously powerful concept. So, if you take one thing away from all this, let it be this. The real power of the cloud isn't just about renting someone else's computers. It's about these sophisticated layers of network virtualization that give you the power to build incredibly secure, massively scalable, and unbelievably flexible networks on demand with nothing more than a few clicks. And that leaves us with one final, kind of mind-bending question. We've successfully turned physical routers, switches, and firewalls into pure software, into code that can be changed, deployed, and automated instantly. So if your entire network is just code, what does that even make possible for the future of applications, security, and the internet itself?